So tonight is all about probability and how it works in a specific sample space. And so the main thing that you need to know, especially when you're answering things, is that a probability is going to be between 0 and 1. We don't say you have a 150% chance of winning, or there's a 190% chance that it's going to rain. Probability is going to stay in between 0 and 1. It's going to be a percentage lower than 100% or exactly 100%. And so really we need to know the difference between an event and a sample space. So a sample space is specifically all the possible things that could happen. And then the event is either one thing or multiple things happening within the sample space. So you'll kind of see here in a second with some coin flips and things like that, the difference between a sample space and a specific event. Okay. And so the first one starts out with just rolling a dice, or just one die. And so we've got an event and an outcome. And so the event is when it's one or more of those possible outcomes, whereas an outcome is just a single probability. And so it kind of breaks up here between rolling a 3 is an outcome, but rolling an odd number is an event that happens with multiple outcomes. Okay, so kind of the outcomes are within an event. I would say the outcome is the least important. In my opinion, you mostly just have to know the difference between an event and a sample space. Okay. A lot of like words there. And so we'll get into a specific scenario right here. And so we've got a cube, 6 sides on it, and we're going to roll it. And so the sample space is anything that could happen. So a lot of times what you'll see is they'll do like these little fancy brackets right there. And anything that could happen could be that you could roll a 1, you could roll a 2, you could roll a 3, 4, 5, or 6. And so that is the entire sample space. Whereas if you have to list outcomes or events, that's just like a part. It could be the whole sample space, but it's usually just a part of that sample space. And so if we're looking at all the outcomes for the event, rolling a multiple of 3. And so again, I don't really love the word outcome because it's not that hopeful. But those multiples of 3, so a possible outcome in general would be multiples of 3 are just 3, 6, 9, 12, 15, all the way forever. But you don't have an infinitely sided die. You just have a 6-sided die. And so the only outcomes that could specifically happen would be a 3 and a 6. Okay, you can't roll a 9, you can't roll a 15, you can't roll a 21. And so 3 and 6 is specifically the outcomes within that event of rolling a multiple of 3. Again, try not to get too bogged down with the difference between an outcome and event. Really, you just need to know what's possible in your specific scenario. So when we're looking at the second scenario here, we've got this box with 3 cards in it, and then a bag has 4 balls in it. And so they're randomly picking a card, and they're going to randomly pick a ball as well. And so when it says give the sample space, giving all the outcomes, a lot of times I like to just think about it like concretely for a second. So you could pick a 1 and you could pick A. And so since you're doing both things, 1 and A would need to go together. So we're going to call one of the outcomes, you could call it 1A. You could have called it A1. It doesn't actually matter because you're always going to pick a letter and a number. You could have picked 1A and 1B, or sorry, and B, and you could have picked 1 and C, okay, as well as 1 and D. And now that's all the possible scenarios of drawing a 1. And so now we would just kind of move on to drawing a 2 here. So you could draw 2A. You could draw 2B, 2C, and 2D as well. And so essentially, you've only got one more possible scenario here. You could draw 3A, 3B, 3C, and 3D. So again, that's going to be your entire sample space, because the reason why we're not separating like the letters and numbers is because every event is going to be involving a letter and a number. So that can be a common problem there. Like sometimes people just want to name, they might just say like 1, 2, 3, and then ABC as the sample space, but you have to actually pair together each possible scenario because of what they said that is happening. If they said that they were only picking a card or a ball, not the word and there, you could have just listed 1, 2, 3, and then ABC if they were only going to pick one thing. So when we're supposed to give the outcomes here for part 2, you're just looking at anything that involves a C, which looks like that is 1C, 2C, and 3C. So if we're going to talk about that specific scenario, we would just say, with our fancy brackets, we would say 1C, 2C, and 3C. By the way, the fancy brackets, that's called set notation. If you're ever messing around and you're like, why are they doing that? Because anytime you're going to use talking about a collection of things, you're going to use those brackets. So even when I did set notation there, you can see that almost every picture involves those fancy brackets. And so that's just kind of how it goes, especially if you take any kind of probability classes moving forward. That's going to be something you got to deal with, not just normal parentheses. And so now you're getting into actual probability, like the way you're probably thinking about it, other than just this theoretical stuff up here, where you're actually going to get a specific percentage or a fraction for how things are going to happen. And it's basically, you just divide the number of the outcomes divided by the total sample space. So like in this scenario up here, if I had to divide these, there's 3 outcomes right there. Like if I wanted to know the probability that you chose C, it happened 3 times out of, it looks like there's 4, 4, and 4, so 12. So you have a 3 out of 12 shot of getting a letter C. So again, that could get reduced down to 1/4, which is the same as 25%. So essentially you just have a 25% shot of picking the letter C. Okay. So you're just going to do the part, the specific outcome divided by the entire sample space usually. So when we're looking at these coins being flipped here, this is kind of a frustrating, not frustrating, but just like longer question than is really fun to deal with. So if you have 3 coins that are flipped, a lot of times you'll see like a tree diagram, which I'm going to do right here. You could have, in your first flip, you could have flipped a head or a tails. Okay. This is a lot of times what people do to figure out the number of the possible like sample space, which I think is pretty helpful. If you flipped a head, nothing really changes for the second flip. You could still flip a head or a tails. It's not like the previous question where maybe if you took out a red ball and you didn't put it back and then you picked out a blue ball, that would be something different. But since it's just coins being flipped, nothing changes in between the flips. If you flipped a tails, you could also flip a head or a tails again. And then for the third flip, you again, nothing changes. You could do a head or a tails again. So you could have a head and a tail, a head and a tail, a head and a tail, and a head and a tail. And so in theory, you should be able to just kind of go down the tree and that will tell you your sample space. For example, if I just look at these first top three, that would give me a sample space of head, head, head. If I looked at the only difference, you can count it however you want. I like to go like, since I did these top three, I want to keep the top two the same and just move down one in the tree. So that looks like you could have head, head, tail. And so since I've done with that top purple tree, I'm going to move down to the blue, the first blue tail. So I'm still on my red head. And it looks like I've got head, tail, head. And then if I went down one more, I would have head, tail, tail. And that would put me at the end of the head, the first red head scenario. Okay. So these have all been taken up by the four possibilities over there in green. And so now I just work my way down to the bottom red here. So that would be something like tail, head, head. Again, the actual matter or order does not matter here. I'm just making sure I don't repeat anything. And then it looks like the next one down would have been head, tail, head, tail. And then the last two would be tail, tail, head, and then tail, tail, tail. So in like a nice little world, like if you look at the answer key, it's probably listed all out like this. But when you're just kind of listing it out and you're just trying to figure out the situation, you're probably not going to write it in that set notation. You're just going to write out these those 8 possible outcomes. Okay. So if you've got a situation, it's asking you to find all the situations where you have 2 tails. So I'm just going to go to my green list and circle all the ones that have 2 tails. So it looks like that has 2 tails, that has 2 tails, and that has 2 tails. And so what can be annoying is that you might be tempted to circle this last one as well, which I agree with you that it has 2 tails. But usually if it wanted to include that one, it would probably have the word at least, like you can see for B and C, it has at least or at most. So we're actually going to technically not include that last one. And we're just going to say that it's a 3 out of 8 possibility of only having 2 tails. And if you get tripped up on that on like I think it's more specific on Alex than here. So feel free to email me if you're like, dude, that's annoying. I put 4 out of 8 because it didn't say the word only. Feel free to just email me that and I can give you a points back for that. So that's a little tricky. I would prefer if it had the word only there as well. So for part B, it's looking at least 1 tail. So that looks like we would have this first one here, the next one right below. And then I would include this one here because there's 2 tails. And so I only need at least 1. So I'm going to include it. Next one down has 2. Next one has 2. And the last one has 3. So it looks like this has a 7 out of 8 shot to get at least 1 tail. And then lastly here, at most 1 tail. So you could have no tails because it says at most 1. So you could have no tails, which would be head, head, head. And then you're just circling anything that only has 1 tail in it. Which I think that's just those 4, which would be 4 out of 8. And then you definitely want to reduce that down to 1 out of 2. So if you're looking to make some money, and you had to bet, you'd probably want to pick part B because you have the highest chance of getting at least two tails, a 7 out of 8 possibility. So this one is going to get more into the a lot of like reading involved here, and you got to kind of like look back and forth and just making sure that we understand what the question's saying. So if there's 75 balls in the hopper, okay, that's probably going to be a candidate for our sample space, which would be the denominator, most likely. So again, basically that sample space is usually going to be the total, which again, in this case is the 75 balls. And then it says in increments of 15, things are labeled B, and then I, and then G, and then O. And so basically it's looking at find the probability of each thing happening. So for N42, I think there's only one of those. Like there's not a G42 because 42 is not in the G spot. There's not an O42 because 42 is not in the O spot. And so I think there's only a 1 out of 75 chance to get that right there. And so not a high chance there. The next one down says N11, which if you look at 1 to 15 are in the B spot, and 11 can't be with N. So there is a 0 out of 75 shot of getting N11 because 11 is with the letter B. Okay. And then looking at a number less than 50. So it doesn't matter if it's a B, it doesn't matter if it's an I, it doesn't matter if it's an N, doesn't matter if it's a G, as long as it's less than 50, it's good to go. So it's not including 50. So that means that there's 49 numbers that are less than 50 out of the 75. And so that means that's our percentage there, or our fraction. So out of all those, you would want C. You definitely don't want B because it literally can't happen. And so C would have the highest probability of happening. A couple more questions here, and then we'll take our first break. So every time something does not occur, you can do whatever you want, honestly. But there is like this thing called the complement. And complement just means the word not in this scenario. And so if I ask like, what's the complement of raining, it would be not raining. Or what's the complement of hitting a home run? The complement would be not hitting a home run, or whatever the scenario would be. Even if you said, what's the complement of drawing the letter B? The complement of drawing the letter B would be any I, any N, any G, any O. So again, complement just means not the specific thing you're talking about. And a lot of times it's denoted with a prime there. So like if I said the probability of raining, if you wrote probability of raining prime, that's the exact same thing as the probability of something not raining. Which you're probably sitting there and saying, that's dumb. Just say what you say in purple and don't deal with the apostrophe. Or again, you probably heard me say prime. Yeah, I didn't make this stuff up. So if that's annoying to you, it's probably annoying to most of you. So yeah, basically the purple and the raining with the apostrophe mean the exact same thing symbolically. Don't get mad at me. You can get mad at whoever figured this out or came up with that notation. And so last year when I did this question, I was like, oh gosh, just like not necessary. Anyways, but so there's 32 trials, 5 homicides, 12 drug charges, 6 assaults, and 9 property crimes. And the jurors are assigned randomly. And so what's the probability that a given juror will not get a homicide? So again, we could say the probability of not homicide. Gosh, or that you could get it in green. You could say homicide crime, which again, I realize you're probably never going to write the thing in green, maybe not even the thing in purple either, but it's still good to know the notation. And so what you can do is you could just count up everything that's not a homicide. So that would be 15. Sorry, just kidding. That would be 12 drugs, 6 assaults, and 9 property crimes, all divided by the 32 cases. That's not completely true, Megan. You might find yourself in Vegas sometime trying to win some money. And so when you add up 12, 6, and 9, that would give you a 27 out of 32 shot. But if I want to do it like it says in salmon up there, you also could have done the fact that the probability of a homicide, I'll do it in a different color. The probability that a homicide is happening is 5 out of 32. And so you could have done 1 minus 5 out of 32, which right now it kind of seems dumb, like not helpful. But there will be times where it's like so much quicker to just do the 1 minus thing. So if you would have a calculator and that would be a decimal. So don't get too tripped up with the fraction work here. But if you had to subtract those, 1 is the same thing as 32 out of 32 minus 5 over 32, which again is 27 over 32. So again, in this scenario, it made more sense probably to do the purple because we can count a lot quicker, and we'd rather do that than subtract fractions. But the red, especially if it's a decimal, is a lot less intimidating and way quicker in other scenarios here. So if we look at part B, so we're looking for the probability that a juror gets assigned to a case that's not a drug offense. So if we found the probability that it was a drug offense, that would be 12 out of 32. So if we wanted to do not a drug offense, my pen's like sticking, which makes my crappy handwriting worse. If we wanted not having a drug, we would just do 1 minus whatever we got for the probability of the drug, which was 12 out of 32. So subtracting those two things would give you 20 out of 32. And I know we don't really want to simplify this, but just out of good habit, that's the same thing as 10 over 16. I just divide the top and bottom by 2. 10 and 16 are both divisible by 2 still, so we can do that again, and that would be a 5 out of 8 chance. Again, the 1 minus will make your life easier if it's in a decimal, in my opinion, and if you can't count because of the given situation. So Empirical basically just means like, I think of like a test or like a scenario, like research when I do that. Whereas like this theoretical probability is like things are just happening, not necessarily like this empirical stuff is usually like rolling a dice, flipping a coin, dealing cards. It's still division, but it's just a little bit, the semantics are just a little bit different. So if we've got this 2-peg mound of Hershey's with the 33, 27, 26, and 16 kind of bar, or sorry, 19 kind of bars. So essentially, when it says selecting a Mr. Good bar, there's 26 good bars out of the total bag. Okay. So I would need to know what is the total in the bag by adding all those up. So 2 pounds is not helpful. So make sure you don't divide by 2. I saw that last year, that 2 can be kind of a distractor. So adding all those up gives you 105. And so I'm just going to divide 26 by 105. And if I do that, it looks like I get, when we go to the thousandths. So that'd be the third decimal place. So 0.248. So as you can read with part B and part C, it's not like having you pick a bar and then pick another bar. It's just like, it's assuming the bag is full. Okay. And so selecting a crackle or a special dark chocolate. Oh, typo. That's tough. So a crackle would be 27. And then the special dark would be 19. So you would have to add those and then divide by 105. You could have done 27 divided by 105 and then 19 over 105. That mathematically works as well. But I like when it's like all in one fraction personally. So 27 and 19. And I'm going to divide that by 105, which would be 0.438. And lastly, here's the probability of not selecting a milk chocolate bar. Again, in this scenario, it'd probably just be quicker to do 27, 26, and 19 together. So you could just do 27 plus 26 plus 19, because that's everything that's not milk chocolate, all divided by 105. Which, if you do that, you get 72. Which, dividing that by 105 gives you 0.686. But again, if you want to use that 1 minus scenario, you could have done 1 minus 33 out of 105. Either way works. I think the 33 out of 105 is 0.314. Yep. And subtracting those would give you 0.686. So again, either way works. In the scenario so far, the purple way has not been quicker. But there might be times where it's nice to use. So just kind of keep that in mind. last one here, and then we'll take our first break. And so we've got this 6-sided die, and we're rolling it 200 times. And so we're trying to figure out the probability of rolling a 4 or a 6. And so really this answer should be like out of 6-sided die, a 4 or a 6 would be 2 out of 6. Like it should be 1/3. That's the theoretical probability. But notice this is asking for the experimental probability. So what actually happened, we rolled a 4 37 times, and we rolled a 6 39 times. And out of those 200 rolls is what we got. So I believe when I do that, I get 0.38, which is pretty close because in purple over there, it's 0.33. But the theoretical is rarely the exact same as the experimental. That's why gambling is great, because you don't actually know what's going to happen. And so same thing here. Oh, we just did that. So oops, went out of order there. What I've got in purple there is what we could do for that theoretical probability. Sorry, I got ahead of myself there. And so as the number of rolls increase, would we expect the experimental and theoretical to become closer, farther apart, or must they always be equal? Well, you can definitely see that they're not always equal, because the red and the purple are not the same. So think about that for a second. If you rolled this, 1,000 times or 10,000 times, in theory, it should eventually even itself out. That's probably not always going to happen. But in theory, it should become closer to 1/3. Or the 0.33. Not guaranteed, but in theory, that's what should happen.